Hi, I'm Matt Wilson, Senior Product Manager at GitLab. I work in our secure stage, and I focus specifically on vulnerability management. I want to talk about thinking about vulnerabilities a little bit differently, specifically treating them like they have a life cycle, like a software product. Now, before we get into that, it's worth reiterating why we care so much about vulnerability management. So the cost of data breaches, usually as a result of a vulnerability, is staggering. So by some estimates at the end of 2019, it was over $2 trillion globally. And some projections put it as high as $6 trillion by the end of 2021. The average data breach cost just for a US-based company was almost $9 million at the end of 2019. And it's increasing at a double-digit rate every year. You can see as the size of the breach goes up, as you have millions or tens of millions of records potentially involved, the cost can reach into the hundreds of millions. Now, it's worth pointing out that in many of these cases, the breaches were not the result of a nation state attack or deploying a cache of 0 days. Many of them were simple oversights, misconfigurations, or common security problems that appear in the OWASP top 10 year after year, things like SQL injections. So having vulnerability management in place is extremely important, but also considering that every vulnerability that leads to a breach is caught at the end of this life cycle. So let's look at a little bit more closely about what I mean. So if you think of a vulnerability in similar terms to software, it has a beginning, middle, and an end. Now, of course, we're talking about vulnerabilities in software for this presentation, but this could just as easily apply to hardware or even something physical like building security. So at the very beginning, it starts with something being overlooked. Now, this is maybe something in the design that wasn't accounted for, something that's in planning, or maybe just an unknown that wasn't considered. This is going to lead to the actual creation. A weakness is introduced into code, where the weakness is the code itself, or maybe something wasn't coded to prevent a potential weakness. Now, after the introduction of the weakness in the code, it actually has a period of evasion. So this means that it's not caught by testing. This could be manual testing, automated unit testing, or even automated security scanning. Once it's past that portion, it becomes incorporated. So the vulnerable code is now merged into your release or your production code base, and it's sitting waiting for the next step, which unfortunately is escape. So that code is now released into an environment where it's now exposed, it's accessible. Now, I would argue at this point, this is where a weakness becomes an actual vulnerability, because up until this point, it wasn't in a place where it could be exploited. But you've now have this code. It doesn't even have to be on the public internet. It could be an internal system, but it is in a position where it could potentially be exploited. Which leads to the next step, which is the impact. So obviously, exploitation of the vulnerability, that is the worst case scenario and what you see about in a lot of these high profile breaches, but that doesn't have to happen to cause a real cost or damage. So for instance, even the disclosure of a high profile vulnerability, even if it wasn't exploited, can lead to reputational damage. And at the very least, we're looking at the highest cost area to actually catch and fix a vulnerability as opposed to earlier in its life cycle. Now, of course, this assumes that there is some sort of detection. To really know about a vulnerability and to do anything about it, it has to be uncovered. As we've seen too many times over the past few years, some of these vulnerabilities have existed in some of the very common pervasive tools that we use for years, if not decades. But at some point, to end a vulnerability's life cycle, you actually have to know about it in the first place. And then finally, you have remediation. So you're taking some action to protect that vulnerable system, remove the vulnerable code, and that ends the vulnerability's life cycle. IBM and NIST have done very similar studies on the impact of software defects in terms of cost and how far down the life cycle you catch them, how the costs increase. We can apply the same cost model to a vulnerabilities lifecycle. If you're able to catch it at the initial design and planning stages, that's going to be the lowest cost and impact. Similar to a software defect, which is arguably what a vulnerability in software is, you're going to see maybe about a 5x cost increase if you catch it at the end of the coding or the creation stage. Costs continue to multiply as you move through that testing, depending on how involved the testing is and how far down the cycle you are. But then all the way to the right, where you would normally detect something in production, that's the highest cost. So you're looking at an estimated between 30 to 100 times more cost. That's just to fix. So this doesn't involve any data breaches or anything like that. This would just be for a regular software bug as well as an unexploited vulnerability, because you have to bring that all the way back to the beginning of the process to do the remediation, test, and redeployment. So you would like to try to catch a vulnerability as early as possible before it can continue to that high-cost portion of its lifecycle. Now, the foundation of any vulnerability program should be some sort of vulnerability management. Now, hopefully you have some software in place that you're using, and you've got a single source for your vulnerability, cure, and risk-based remediation. Now, this is great, but we find that a lot of times it's only the application security teams that are using these tools. If you want to move up in maturity, you need to make sure that your engineering and your AppSec teams are working, if not in the same tool, at least with tightly integrated systems, so they have a shared context and workflow. So everybody is sort of seeing the same things, speaking the same language. Eventually, you want to move to be more risk-driven as well. This is going to support some of your compliance efforts with things like risk-based policies. And if you're leveraging modern DevOps practices, you can actually start to automate a lot of these controls as part of your software development lifecycle as well. There's a lot of talk about shift left. It's a very used, or depending on your preference, overused term, but not enough focus is given to the right side of the equation. So making sure that you're not just focusing on vulnerabilities in the software development process, but what happens to things after they're deployed. So this is the assets and the infrastructure data. Consider incorporating a vulnerability at the end of its life cycle back into those same systems that you're using to manage things at the beginning and the middle. And then finally, look at really extending beyond what a lot of tools and I think coverage talks about today in terms of vulnerability management, which is the hardening from both ends, so beginning and end. At the very beginning, doing things like secure architecture and threat modeling to ensure you're minimizing vulnerabilities being introduced in the first place. And then also looking out on that far edge of the end of the life cycle, doing things like breach and attack simulation to try to catch any missed vulnerabilities in the process before an attacker does. So when we think about engineering, IT ops, and AppSec, a lot of the old silos still exist. Now, the situation is definitely improving, but as we're going to see, some of it is better in certain areas than others. So GitLab runs a global DevSecOps survey every year, and the 2021 results had responses from over 4,000 individual practitioners in the field from across disciplines. One of the interesting findings is that almost 40% of developers are now feeling fully responsible for security in their organization, and about a third said that they're sharing this with other teams. If you look at the numbers on the right, you'll see that there's kind of a similar breakdown on the security side. So when asked who is responsible primarily for security, about a third of security teams says it's solely them still. But interestingly, over a quarter says it's all of the above. So it's a combination of security teams, developers, and the operations teams. Now, this is great that they're starting to share responsibility for security, but it doesn't necessarily mean that the tools and processes that are going to help make them more efficient and increase some of these friction points are actually being addressed. They're just sort of shifting out some of the responsibilities. And we see this in some of the responses from the security teams. Their main sticking point is that the testing itself is really not going the way that they would expect. So high percentages say things like it's happening too late in the process, that the struggle to unpack, process, and fix. So if you want to think about the actual triage and remediation process is challenging. It's tough to track the status of bug fixes. So this speaks to using different tools and disconnected processes to actually identify and then manage the remediation of vulnerabilities. And we think that the reason for that is the way that traditional AppSec is set up to create these silos and friction points. So if you think of a developer working inside of their code, they're committing maybe into a CI system, maybe you're not using CI/CD, but you're going through a normal development cycle in a very linear process. Developers work on code, introduce a new feature, And at the end of their cycle, it's eventually deployed to an environment, hopefully a test environment, not production. Now, this might be your typical agile cadence of 2 to 3 weeks. Well, at the very end of that, the final finished application in the test environment has some sort of security scan run against it, typically a DAST scan, some sort of dynamic test. The output of that is a security report, which typically goes to the security team, who is going to analyze something without all the context of exactly what got introduced, what was new. And they'll probably take that and throw it over the wall back to the engineering teams with a list of security findings or vulnerabilities that need to be fixed. Well, that delay in the cycle and that lack of integration between the two teams makes it very disconnected and inefficient. The developers probably already moved on to another feature, the next iteration cycle, by the time they get this vulnerability report. And it's not really tied to the features that they were developing. So a better model for that is to try to really leverage a lot of these modern DevOps tools. You probably already have engineers and security team members participating in them. And if not, there's definitely a chance to get them much closer together and to tighten those iteration cycles. So for the developer, as they're committing code, rather than waiting to do any sort of testing until the very end, the deployment stage, you need to incorporate these security scans, these automated tests, into your continuous integration pipelines. So as that developer commits code, every single commit, you have the opportunity to scan. You'd perform your static analysis, your secret detection, dependency scans. Now, if you're leveraging a tool that's similar to GitLab's, we actually have a feature we call review apps. It's effectively an ephemeral container that we spin up as part of the CI pipeline process, which is a complete running version of the app. Now, you could use that to do things like run your dynamic tests, your DAST, your fuzzers. You can also do container scanning as well. What this does is it creates a very tight feedback loop for that engineer. They know every single code commit, not just a full completed feature. Have they introduced any new weaknesses? Are there any new vulnerabilities? So they have an opportunity to remediate them as soon as they're introduced, instead of getting a report several weeks later. Now, if you've brought your security teams in as well, you'll see that at the end of this iteration cycle, they get the same results from the CI running on the main branch as you're deploying. What's important to point out here is if you're doing a process like this, not only does the security team have a same shared view of vulnerability findings that an engineer could also look at, there's probably less that's getting downstream to them. Because the engineers are able to actually fix and address things earlier in that life cycle, you're not waiting until much further down. So you're actually taking some of the burden off of those security teams. So let's zoom in just a little bit further into that developer workflow. So we're hopefully talking about, at this point, we're integrating our security teams into our engineering tools and workflow. Now, you also notice if you're going through this process, this is where you start to have automatic compliance enforcement abilities. So since the security testing is embedded into that developer's workflow, you can actually have the security teams make sure that you're enforcing certain scan policies, making sure particular types of scans are run and with particular configurations, so that every commit is basically going to an enforced scan policy. I know, for instance, in a lot of cases, regulatory requirements require a static analysis scan. So by doing that earlier in the process, you're going to have results that are a lot cleaner when you get to the final analysis at the end before release. Now, the other interesting area is you can insert approval workflows. Much like you would have a code review, you can actually have a security review as a kind of final gate. So if the developers, let's say that they don't fix all the vulnerabilities or there's something they're not sure needs to be fixed prior to release, it's an opportunity for the security team to have final say on what gets merged and then ultimately released. It's kind of a fail-safe. It does add a little bit of friction into the process, but it also allows the proper amount of oversight and potential compliance. So your security team can either send it back to the engineer if there's a vulnerability that needs to be fixed, or they can make an exception, which is documented in that same tool. So this is pretty common for a DevOps flow. But in terms of vulnerability lifecycle management, there's some pieces of this that are missing and are not typically incorporated into DevOps tooling. So on the left side, we have the design side. So this is really everything that goes on and happens before you start developing the code. And of course, on the far side, you're probably monitoring your applications, but we want to make sure that you have all the active protection you need and that you're putting results from that active protection in the right place. There's also the question of unknown assets. So one of the challenges with continuous deployment is you may know everything that comes out of your CD system, but there could certainly be parts of your environment, containers, cloud instances that you may not have visibility in your DevOps platform to. And these vulnerable assets, or any vulnerable assets, can cause a big problem because you're not necessarily handling them the same way. So let's think about that right side first. The active protection side of things, hopefully you're doing all of the best practices. You have vulnerability detection, malware scanning, configuration hardening. So you're checking regularly for security misconfigurations or access privileges where they shouldn't exist. Now, one thing that we like to advocate for if you're using modern DevOps is infrastructure as code. So you're effectively taking your configuration changes to your infrastructure just like you would any other source code. You're checking it in and out of your repository. You are making modifications to it, committing that back. You can actually run that through your CI process. So you can automatically test it for any misconfigurations where you have, let's say, a test case set up for, and then ultimately deploy it back out to production. So you could make that change to, let's say, your Kubernetes environment or a container in a pretty automated fashion. The one thing that I don't see as much is on the vulnerability detection side of that, feeding that information back into the same vulnerability management system that you've already got set up that's covering your application development process. You've already got the security teams and you have the engineers that are ultimately going to fix a lot of these issues. So you need to make sure that you are putting that information in the same place so you have one single source of truth for the two teams that are ultimately going to deal with a lot of this. And another area which often sees a disconnect is on that alert side. So if you have an incident response team and they find something that actually turns out to be the result of either a vulnerability or maybe there is a security misconfiguration, you need to make sure that that gets put into a ticket in the vulnerability management system in the same way as any of this other information. Now, if you've taken time to try to integrate all these systems together, that's a lot easier and you're not dealing with emails, spreadsheets, or let's say maybe one team is working in Jira and the other is in ServiceNow and you're copying and pasting in between. So again, the goal is trying to take all of this different information and increase your visibility and decrease friction by making sure you're putting everything into the same place so that everybody is working from a shared view. Now, on the unknown asset side, there's a reasonably new term called attack surface management. And basically, this is automated asset discovery. So this is trying to look for anything in your companies or subsidiaries control or space that maybe it's a forgotten asset. For instance, it's a long-running container that nobody remembers was there anymore. It's an unknown asset. It could be a rogue asset. The idea is you need to have a total view of everything that your company is responsible for and may not be part of that CD system or may not come out of your CD system. A lot of these attack surface management tools will also allow you to do some form of asset management, which is great because you can create these asset groups and assign them risk profiles. You can put newly discovered assets into the groups, or if it's something that is, let's say, out of policy, you might need to make a configuration change to block these newly discovered assets from entering one of your defined asset groups. Now, again, feed vulnerabilities back into your vulnerability management platform. So many ASM tools will be able to alert you to things like, hey, we discovered a container that's using a vulnerable image, or this is running an out-of-date unpatched web server. You need to make that kind of an update. Just like you would for your actively monitored assets, you need to make sure that this is coming back into that same vulnerability management system. Leveraging infrastructure as code, you could do the same thing with any configuration changes. Do you need to incorporate those assets, or do you need to potentially, let's say, block them from entering one of your clusters? And finally, if you use those ASM tool outputs, you have an idea of what your total attack surface is. The idea is to continue to minimize it and to harden the surface. So you can use that as the basis for automated external testing, so DAS tools, fuzzing, things like that, as well as manual security tests. Use it for your pen test team. If you're doing that regularly and you have confidence that you understand your total attack surface, you can run a comprehensive breach and attack simulation program. So if there are any weaknesses to be uncovered, hopefully your groups are finding them before an external adversary does. So going back to the left side of the input side, a lot of this is really around adopting secure SDLC practices. So if you haven't already, Microsoft and NIST provide 2 good reference points that you can start with. But there's a few key things to keep in mind. You want to make sure that you've got well-defined security requirements that you keep updated. So it's not just about functionality changes, it could also be regulatory and threat landscape changes. Now, these security requirements, it's great if you're documenting them in your DevOps tool, but even better is if you're using these to generate automated security tests, things that are running in your CI pipeline, so that you can, again, reduce that cycle time and increase that confidence that things that are getting put through your development process are actually matching security requirements, and you're trying to minimize those new vulnerabilities from getting introduced. Another important piece is security training. Now, this one may be a little bit more foreign to introducing directly into a DevOps platform, but many developers are not security experts. You want them to have awareness of the latest risks and mitigation techniques. It can work if you kind of give everybody a big one-shot training, but what we find actually works better is if you can give them sort of in-context interactive lessons that the developers can access as they're developing code. So for instance, as the results of, let's say, a security scan come out of your CI pipeline, and the developer is looking at the results, you could take one of the CWEs of one of the potential weaknesses they were to introduce and give them a little interactive lesson based on that CWE. So they actually have something practical and highly relevant to the work that they're doing. And we see that this is often the best way to get not only engagement from the developers, but increase the quality of code over time so they're not making the same security mistakes. And then the other big component to that is threat modeling. So you're trying to identify all the risk sources and mitigations before they create problems. There's a number of different systems you can use for threat modeling, but you're effectively trying to detail out all of the potential avenues of attack for your particular function or application. And again, this can go hand in hand with some of your security requirements and your secure architecture, and should drive some of the testing, the automated testing and checks that you've started baking into your DevOps process further down. So if we look at the DevOps loop that I think most of us are familiar with at this point in time, if you're adopting these modern DevOps practices, you hopefully also have a single DevOps platform, or you at least have a tightly integrated tool chain. There's going to be touch points at every step in this DevOps process where you can try to identify and stop vulnerabilities. Of course, this is not comprehensive, but to illustrate that if you're integrating not just more tools into your process, but also your security team and techniques, you're going to truly enable DevSecOps, where everyone's working with the same view, processes, and understanding from a vulnerability management perspective. So we're going to go back to where we started with the vulnerability lifecycle. Now, of course, the goal is going to be to stop vulnerabilities before they ever get a chance to progress, where the impacts and the costs are going to be lowest. But of course, this isn't 100%, isn't possible 100% of the time. So what I hope you'll take away is that by thinking about how you can bring your engineering, ops, and security into closer collaboration, into the same tool sets, or at least create shared workflows and views, and you expand the edges of what you consider part of this process all the way to the left and to the right, you're going to see that your DevSecOps processes have tools and techniques that you can map to dealing with vulnerabilities, no matter where you encounter them in their life cycle. Thanks for watching. I hope you enjoyed.